If you've ever wondered how teams build software together without constantly overriding each other's work, you're in the right place. My name is Michael Michel, a Microsoft technical trainer. In this video, you're going to be driving into GitHub fundamentals, starting with the basics of how GitHub works and why it's so widely used. Whether you're brand new to GitHub or just need a refresher, my goal is simple. By the end of this, you will understand how teams collaborate, track changes, and manage code using GitHub. And we won't just talk theory. I'll connect everything to real-world scenarios so you can actually picture how this works on a team. So let's get started. For example, imagine you're in a team building a web app. One person is fixing a bug, another is adding new feature, and someone else is reviewing code. GitHub is the platform that keeps all of this organized without people stepping on each other's work. We'll walk through the core building blocks that makes this possible. You'll also see how teams collaborate using tools like issues and discussions, which are basically how work gets tracked and conversation happen in a structured way. And finally, we'll touch on notification, because in real-world projects, staying informed without being overwhelmed is just as important as writing code. By the end of this module, you're not just going to recognize GitHub, you'll understand how it's used in real projects. We'll walk through the core building blocks that makes it possible. We'll also see how teams collaborate using tools like issues and discussions, which are basically how work gets tracked and conversations happens in the structured way. And finally, we'll touch on notification, because in real-world projects, staying informed without being overwhelmed is just as important as writing code. So let's get started with this session. So what is GitHub? At its core, GitHub is a cloud-based platform. It's built on Git, the industrial standard distributed version control system. You can think of GitHub as a toolkit plus a community hub. It gives you a web interface, a command line experience, and an overall workflow designed so teams can collaborate seamlessly. Now, let's just go to one level deeper. What actually makes GitHub so powerful? A helpful way of thinking about GitHub is not just as a tool. It is a platform made up of several layers. Let's break them up using this real-world example. Imagine your team is building a company website. You're not just writing code. You're collaborating with teammates, you're reviewing each other's work, you're making sure nothing breaks, and eventually delivering something reliable to users. GitHub supports all of that through 5 key pillars. Let's start from the bottom. Scale. This is what GitHub makes it very powerful. It is used by thousands of developers. Millions of users are using it around the world. So whether you're working on a small project or a large project, it is there. Security. Think of all the automated scans that can catch things like secrets and vulnerabilities in your code. You will be notified and you'll know about it ahead of time. Productivity. This is where the tool like this pull request, automation, projects, boards, discussions, all of these make the project move faster. And it is the core of collaboration. At the heart of GitHub, features like issues and pull requests allow you to communicate clearly and review work together. And at the top, AI. GitHub has a lot of tools, including GitHub Copilot, that can actually suggest code and help you write function and speed up your development. So instead of thinking of GitHub just as where code lives, think of it as a full ecosystem that supports your entire development process, from idea all the way to production. I want you to think about repository more than just files. You want to think about repository as a smart folder. It will hold all your project files, but also remembers every change you made. History is what lets teams collaborate without fear. If something breaks, you can always roll back. Repos, short for repository, are the foundation of everything we do. On GitHub, we track work, we coordinate change, and we keep projects organized. So let's go ahead and make one. So let's create a repository. The easiest way to create a repository is once we sign into our account, so just go to click Add, New Repository. Click on the repository. That's where things get interesting. In general, you need to choose an owner. So usually the owner is you, the account that owns the repository. You give the repository a name. For example, Hello World. Now it needs to be unique. So in my case, I'm going to add v1. Every time you build a repository, you give it a description, such as this is for demo. Here's where it gets even more interesting, the visibility. Do we want it to be a public or private? Public, that means anybody will access it, and private, that means only people within the organization that you choose to have access to. That's on enterprise, but if it's not enterprise, then you have access to it, or people you choose to have access to it. You can start with a template, something that's pre-configured. I always recommend to add a README. It's the best practice to have a README. We also have options with get ignore and licensing that we'll talk about later. If you have a Copilot license, you will have that option available. Once you're done, all you do is create the repository. This will build the repository in the background and takes you directly to it. So you'll see that it has the README, it contains the name of the repository, and you're good to go. Now we can add files that can be code, can be something that is part of your project. So in your repository itself, in my case, this is the Hello World repository. I'm going to click on Add, and I'm going to create a new file. I have the option to upload one, but in my case, I'm going to create one. Once you upload the file, now you can give it a name. So I'm going to give it analysis.yaml. In the content, you can specify anything. You can just give it, for example, this is demo file. Once you give the file a name, once you create the file content, now you're ready to commit changes. Click on commit changes, things get interesting. You can commit directly to the main branch. That is not recommended. So in my case, I am going to create a new branch. A new branch. This is the most practiced, or this is the common practice for here. So for example, if I am adding a new feature, if I'm adding a new settings, so this is creating a new patch that includes the account name plus patch 1. I'm going to go ahead and propose changes. What happened right now is my repository has 2 branches. My repository, if I look at it, I'll see that in my repository have the main and has the new change. In the main, I can't see that file added. When I move to the branch, you'll see there is the file. This is the analysis file that I chose to add. So what am I going to do if I need to have my file merged or combined with my main? That's when you choose the compare and pull request. And what we do is we're going to pull the changes from the patch 1 to the main. You can give a comment, you can do something with it. And upon completion, you can choose one of options. You can create the pull request, or you can create a draft of the pull request. That means it's ready, but not ready, needs to be reviewed. All these advanced steps, we can talk about some of them later on. So create the pull request. This will create a pull request that is ready. Again, depending on your security policies, what needs to be done, this tells me that, well, the change is ready to be merged. And you could choose one of the options. You can merge it, keep the branch, you can squash it, or you can rebase it. 3 options that are available for you. Just going to create the merge and merge. You asked me to create a comment message. I confirm it. And we're done. After this is done, I can see the merge. If I go to my code, I will see that at my main, I have the analysis. And I have my branch, the patch 1 branch, is still here. That's how we add a file and pull the file into our main. And now that we added a file and we looked at how we can create a pull request, let us look at the other parts of how can we use GitHub to share. Sometimes you want to share some code, but you don't want to share your entire code. You don't have to create an entire repo just to share a bite-sized pieces of code. That's when we use gists. Each gist behaves just like a full repo. So you can fork it, you can clone it, you can track it, and you can share it. You can make your gists public, which means that they show up in the global gist directory, and searchable, so anyone can access them. Or you can make them secret, so if you'd rather keep it out of public search. Just remember, anyone with the URL can still view it. What that means is that it is not really secret. Look at this slide. In here, you can see that whenever you choose to create a gist, this is what is going to appear for you. And then at the bottom right, that's where you're going to choose either a secret gist or you want to choose a public gist. I gotta emphasize this point. A secret gist doesn't mean it's secret. Anybody with a URL is going to be able to access it. But remember, this is a very good way of sharing snippets of code with others without having to build an entire repository and an entire file for it. Another interesting component that is used, especially for collaboration, and we see it a lot on open source projects, is Wiki. It's a dedicated space for more documentation. While as developers, we've all used README files. They give you a snapshot of what's on your project. Wikis allow you to dig deeper. So now you can look at usage guides, you can look at architecture overview, you can look at design decisions, or even the team processes that is there. Wiki uses markup, uses Markdown, which means that you will be able to edit it in the browser. It's just part of the repo itself. And if the repo is private, then it is private. It takes the same access control that you have of repo. Only people with at least read will be able to view it. And if they need more, you can give them write, and then they'll be able to edit it. Think of Wiki as your project's living handbook. So any updates to your projects, anything that you want to inform your community or you want to inform your team, you can align it and you can add it on your Wiki. Usually it contains also best practices and key concepts. This is what a wiki looks like. When you create it, you just create a new page, give it a title, and then go ahead and add some descriptions in it. So it can be, for example, welcome to the hello world on Wiki. Once you're done, you can save it. Once you save it, you'll be able to add more information to it. As you can see over here, I can just go edit it or create a new page and add one file after the other. Now, let's look at the heart of the collaboration on GitHub. This is what we call the GitHub flow. Let's start with branches. Let's look at this cornerstone of parallel work in GitHub, where multiple people can work on the same project almost at the same time. So the branch in GitHub is a separate line of development that keeps your changes isolated from the default branch, allowing you to experiment safely without affecting the main code base. You can create and switch to a new branch with a single command, GitHub checkout-b. You can give it the branch name, and every change you make is recorded and is committed to that branch. Your work remains confined. That means nobody else is accessing it, nobody else is editing it except you. This gives you the ability later on to merge it. So you can merge it to your main branch. And now you can delete it, you can remove it, you can add comments to it, you can ask others to even review it. If things, for example, things don't go as planned, you can just simply delete it and start over without disturbing the team's progress. So what are commits? Previously, we were able to add files, and we looked at how we can add those files and how can we create a pull requests. So commits is essentially a snapshot of changes. These changes that you might have made to one or more files on a branch. Each time you commit, you create a unique identifier, a timestamp, and the author information so that you can form a clear audit. This information is really important when you're collaborating because you can keep this commit or you can choose to remove it, change it. Commits can happen to different types of files. So let's break it down into some basics. First of all, any new file that is added to your Get is initially untracked. That means GitHub itself doesn't know about it. So what happens after that? First of all, you kind of like let GitHub know that I want to track it. So the file itself changes from untracked to tracked. In tracked, the file itself can be one of multiple modes. It can be unmodified, And this is usually a later stage. That's why when we think about modify, that means the file has not changed. So usually when you add a file, it starts with modified. That means, well, there are some changes to it. When you are ready to add those files into your staging area, this is what we call the stage. So that means the file changed, and now the changes are being added to the staging area. And after that, you do the commit. That means whatever files, whatever changes were in the commit state, now they are part of your repository. And that is when the file itself becomes unmodified. So every time you add a file, it's going to be modified. After modified, it's going to be staged. After staged, it's going to be committed. So think about it as staged to be committed. And then once fully committed, that means it is unmodified. That means your local files and the files that are available in Git are the same. And we do that through the process of pull request. We abbreviate that into PR. That's the way that we actually propose changes. That's the way give us the ability to discuss those changes and integrate the changes from those different branches through the commit process into the main or the default branch. So every time you want to add code to your main branch, what you're doing is a pull request. You are technically pulling the change from a branch that's where we can add the feature, add the fix for the bug that we have, and then we pull it into the main branch. The main branch is where our code is, I'm not going to say production ready, but it's ready for production. So we think about branches, we think about commits, we think about pull requests. How do they all work together? This is really the GitHub flow. The GitHub flow is the heart of how collaboration and how experimenting and working with GitHub service works. So think about it that you want to start a new feature. Let's say we're going to add a new UI feature into our code, into our website that we're building, or our web app. Now we created a branch. That's the first thing we're going to do. So we're going to create a copy. Think about it that way. So a copy of the code into its own protected environment. And by protected, I mean its own copy. Now we're going to start creating changes. Every time we create change, we're going through that loop. We're committing the changes, and we have the changes ready to be pulled into our main. So we request or we create a pull request. That doesn't merge or doesn't kind of like combine both of my environments at the same time. Actually, what happens is that we go through that collaboration part that we're going to talk even more about later on, is where multiple different users, multiple different administrators are going to start commenting on that code. Now, this is the regular comments, not the commit comment. That means maybe I don't want that change. Maybe I need to fix that specific feature that I have. Once multiple people approve, multiple people request a change, or maybe you have some branching rules that we're going to talk even more about later. Once all of that is decided and my branch is ready to be merged with my main, I'm going to go ahead and do that. So you think about it as multiple step process, from creating the branch into committing the changes once, twice, however your code needs, into creating the pull request, which is a notification in a way that tells people I am ready for my code to be part of a production. To multiple people talking about it, collaborating, thinking about different ways of we can fix it. This is also, even though I'm showing it as a straight line, this can also be kind of like a loop where we go back into commits, we go back into changes and create a new pull request until our code is ready to be merged with the main. The collaborative part of GitHub is very important. Whenever we think about the different options or the different features that GitHub gives me, collaboration is where multiple issues and discussions can happen. Let's start with issues. What is an issue? An issue can be an idea, it can be a problem, it can be something that we want to discuss in our code. For example, I created a field, and this field needs to evaluate the entry. Maybe the entry has a certain pattern. Now, when I run my code, maybe I've noticed that it's not evaluating that pattern, or whatever I'm entering in that specific field, it's giving me an error. Then I can create an issue. An issue can be, again, one of multiple different things. You just give it a title and you say that this is what my issue looks like. So when you go to GitHub and you create your issue, you give it a title, you can use some templates. And users on there will be notified of those issues. Sometimes it's not an issue. Maybe it's just a discussion. That means I want to have an open dialogue into my project. I need to discuss maybe where this project is going. I need to discuss if there are some features that I want to add. So I can enable discussion in my repository. After administrators enable discussions, now I can have multiple developers, multiple reviewers, multiple users look into those discussions and be able to add their thoughts. When you enable the discussions, it's going to show on your project toolbar. And once you click on discussions, you can start different discussions with different categories. You can have announcement, you can have general ideas, you can have ideas, specific ideas that are there. Each one have their unique emoji. Each one has a unique name that can be added to. And those are whatever you choose them to be. So you set the standards. Remember when we talked about wikis? You can set the standards of how do you want your discussions to be ran in your project. These discussions give you the ability to be notified. So what does that mean? That means if a discussion is going on, I can subscribe to that discussion and start getting notifications. And this is the subscription part of what goes on in GitHub. So GitHub lets you subscribe to any thread. You can subscribe to an issue, you can subscribe to a pull request, a discussion, or even a single jest that was created earlier. You can manage those notifications and you can manage those subscriptions. That means maybe I turn them on for a certain period of time and then I turn them off. Why would that happen? Maybe I'm assigned a part of the project that I'm working on and then I'm reassigned to do something else. So I can do that using the notifications and the subscription button. So I can just go to that, let's say, thread, or I can go to that issue and just go to unsubscribes because I'm not interested in receiving notification about it anytime. So this is what we call unwatch or unsubscribe. You can also use mentions, such as a certain qualifier for a specific use. Another awesome feature with GitHub is that you can create what we call GitHub pages. Yes, static pages. So GitHub, static pages that can host information about the repository. They can host information about you. They're built in just HTML, CSS, JavaScript files, and it can have information in your repository. They need to be built in a certain way. We'll talk about that later. Now it's your turn to put everything we've covered into practice with a hands-on exercise. This exercise is available for you on aka.ms/learn-gh-100. Congratulations on making it to the end of the module. Now it's time to put your knowledge to the test with a short 2-question assessment. What is the best way to report a bug on a GitHub project? Send an email to a project owner. Don't bother report software bugs because there's no transparency and they never get fixed anyway. Search for the bug in the project existing issues and create a new one if it hasn't already been reported. And the answer is C. Search for the bug in the project's existing issues and create a new one if it hasn't been reported yet. Suppose you created a bug fix on a new branch. I want it to become part of the next production build generated from the main branch. What should you do next? Copy your branch changes and commit them directly to the main branch. Create a pull request to merge your new branch into the main. On second thoughts, maybe I won't share this fix. I'll just put it in my own private version of the source code. And the correct answer is B. Create a pull request to merge your new branch into the main branch. We've covered a lot of ground in this module. First, you learned the fundamental features of GitHub. What makes it a powerful AI-enabled platform built on Git? Then we drove into repository management, creating repos, adding files, and organizing your work. We walked through GitHub Flow, branches for safe experimentation commits as your project history, and pull requests to collaborate the merge changes. We explored GitHub collaborative tools. We looked at issues for tracking work, discussions for open-ended conversations, and the notifications subscriptions that help you stay in the loop. Thanks for joining us for this session. To continue your learning, watch other videos in this course or explore more on Microsoft Learn at aka.ms/learn.